So I'm going to talk about a project called Bond Redux. It's and I'll explain its name probably if I have time at the end. It is a project that's close to our heart, and it actually tries to do three things that I have to do with the ways we occupy our cities and the way we do architecture these days. One of them is to unlock potential of infill sites in North America in order to intensify the use and reduce the amount of energy and waste that we produce. Two, to reduce the amount of emissions, in particular CO2. In construction, as we know, that takes a large portion of all CO2 emissions that human occupation does. And then thirdly, to affect the housing crisis that we are facing all again across North America. The project's located in a sort of forgotten part of downtown. You see historic context. Currently, it's one large parking lot, and the project site is right in the middle. It's about 30 feet wide by just over 100 feet long, so 10 meters by about 33 meters deep. And with 6 to about 8 stories permitted height. We went on to a design with a client to do the full-on pricing exercise. We're very excited about using mass timber for the project and so on. And then learned one disconcerting truth. We operate in the center of the continent, and where the price of construction tends to be higher because the demand is lower than it on the coast, and yet everything else seems to be more expensive. And what happened at that point in time is we've discovered that we're paying commodity prices for mass timber that can be absorbed by rental or lease costs on either of the coasts. But in the prairies, our structure ended up being priced, so just the wood timber structure being priced over 50% of the entire construction cost of the building, which was completely unattainable. So we bought our client out and sort of went into the research mode to find out why that is. So here you can see a graph that shows that in the center of the continent, 3,500 kilometers north of us, there's only been 3 mass timber projects built in the recent years, 0 of which are in housing or in a market-driven economy. And so we've discovered also that most of the mass timber construction in Canada and in the United States, in North America, and which is what our pricing was based on, is based on glue-lam, so glue laminated wood and cross-laminated timber, and that requires a series of proprietary conditions, certain erections practices that are not available to smaller markets and so on, that drive the cost up. Digging deeper, we've discovered that the amount of connections and the size of wood required for both to achieve the rating and the structural integrity or strength of the project are immense. So in order to get wood in the buildings, we're doing a lot of steel compensation to bring that up to building codes and the structural seismic requirements and so on. At the same time, the property that we have in our hands repeats ad nauseum throughout the prairies at 33 wide by 100 feet deep, so we seek for an infill solution. One of the critical aspects of a building like this, which is disproportionately narrow, is the fact that it has requires a lot of lateral support. That paired with the fact that we can't build wood on the property line sort of led us to thinking that we need to, first and foremost, try to figure out ways to act and resolve the lateral support. So we've tested different frames, moment frames, things that are similar to what you see on every timber project, and they either failed or required a significant amount of wood. Then as we deployed the diagrid system that you see here, there's nothing novel about diagrid, but I'll talk what's new about this one. We're able to reduce the amount of used wood down to 28% of a typical, so almost a quarter of your typical post and beam moment connection building. In the area, we've dabbed with NLT construction, so nail laminated timber rather than glue laminated timber in the past. We have a person or a contractor who's willing to work with us on that. The other thing that we've discovered through the process is the amount of waste that every piece of wood goes from the mill all the way down to a construction of a CLT panel and so on. And almost 45% of wood fiber is lost through different planing and machining of wood. And so here you can see one of our test diagrid elements. And so we've tested, with structural engineers, tested different disposition or distribution of those members through the building, and so on, tested different ways of constructing it, and arrived at a very simple 2-story frame that can be built by any framer. So if you are from North America, you understand the framers are abundant. They operate with tool belts and nail guns, and if they can build something like this, instead of us going through proprietary technologies, connections, and so on-site or pre-manufactured off-site, using just nail guns, that became our target on how to make this, the mass timber affordable. And so the structure of the building consists, as you can see on the screen, of A or a V type columns with the intermediate and top beams integrated in those columns with the very simple HSS top and bottom connections. Two of those get bolted together, and the frame stands up and provides all the support both for gravity and for lateral in the building itself. So in terms of energy, it drops down to about half of the 2030 target when it comes to EUI, and then we are at about 89% less on emissions than the baseline when it comes to CO2. The other aspect of this is trying to test the separation between suites in terms of the sound and fire, and we are testing 8 different systems at the moment through the laboratories in order to eliminate all the concrete, because typical solution to this in our climate is pouring 2 inches of concrete in the building. So we're trying to eliminate all of the concrete in order to meet these CO2 guidelines. So the suites now, instead of having your typical post and beam connections and configurations, are inhabited by these 3-dimensional trusses. There's only 2 different floor plates, but again, due to alternating, we can achieve 2 different appearances on either of the end facades. And a critical part of the entire timeline of the project and the speed of erecting wood, those of you that have worked in mass timber know that speed is essential because of the damages that can occur to wood, pre-manufactured wood. We are developing an infrastructure pod. So there's 24 of these infrastructure pods, 1 per suite, going into the building, and each one of them contains a bathroom, a kitchen, a beginning of the kitchen, laundry facility, mechanical systems, and sprinklers. So we are eliminating infrastructure from the rest of and electrical distribution, eliminating infrastructure from the rest of the building itself, therefore reducing the amount of time the building has to spend exposed. There are 4 residential units. So again, going back to the basics of the project, there are 4 residential units per floor, 2 bedrooms, 2 1-bedrooms, and with office spaces on the bottom floors, and some housing support spaces. The hallways are open, therefore permitting air circulation across the building, and the windows, therefore, can be on either side of the units. Therefore, units are getting the cross ventilation itself. One additional code, there's a myriad of code attacks, code attacks that we're doing in the project in order to make it fit within the existing building codes in North America. One of them is moving the building into a single stair category. Typically, every building in North America requires, above certain size, which is very small, it requires 2 exit stairs. So this building will have 1 exit stair, which is very critical. We're pushing for a new classification of the building, new ratings that allow for 7 and 8 stories building to be built at lower rating than the high-rise building. The ground floor contains support spaces, contains offices, and it's sort of a 2-story space with a mezzanine, again, taking advantage of 2 ends as access to light, and working with, again, flexible space throughout the space with the opportunity to spill out onto the sidewalk and so on. And then lastly, as in a pursuit of reducing the CO2, there's an interesting conundrum where we live, where energy that we have is super clean. The building is fully electric. Energy we're getting is super clean. We're still trying to figure out, because it's all hydro, so we're trying to figure out what's more environmentally responsible, to install photovoltaic panels, and we're photovoltaic panel ready on the building, both on the roof and the south facade, or divert all the waste from the photoelectric panels that have 15 to 20-year lifespan and actually stick to a clean hydro energy that's abundantly available. So anyway, that's the last part of the project that I need to talk about. Thanks, Jeremy.
Thank you.